Hello everyone, it's December the 5th. Alright, let's take a look what we have today. Maximum number of something. Maximum number of integers to choose from a range. You're given an integer array band and two integers n and a max sum. You are choosing some number of integers following the below rules. The chosen integer has to be in the range from 1 to n. Each integer can be chosen at most once. The chosen integers should not be in the array band. The sum of the chosen integers should not exceed max sum. Return the maximum number of integers you can choose from the mentioned rules. So I cannot choose anything from band. Let's switch. I cannot choose anything from band. I can only choose from 1 to n, and the sum cannot exceed maximum. So I basically go 2 pointers again, right? So basically we want to choose as small a number as possible. So we start from 1, right? And then we check with band. It didn't say if band is sorted though. It did not say, but we can verify it by, make it not sorted. Oh, it's not sorted. 165. Yeah, it's not sorted. Nobody says it's sorted. So we sort it first, right? And then we will go 1. Like if it's in there, then we swap to the next one, and this will move forward. And also it didn't say if it, I don't know, can it be duplicates? I have no idea. Probably cannot be duplicate. Oh, it doesn't really matter, right? Doesn't really matter. So you just, duplicates. What do we do with duplicates? Band duplicate. It will be stupid if they have duplicating band, right? So, but when you move forward, because we want to prevent the situation where duplicates will haunt us. Look great. You ready?
Kirkland tomorrow. Me, her, and me. Seattle's too long. At least on Fridays.
Okay. We go to Kirkland.
I don't have to know.
Okay. Tomorrow, going to Kirkland. All right, I'm back. Let's continue. Basically, once we check something match, we just we move forward. If it's the same as before, we just keep moving forward until it's not the same. Yeah, we always stop at a new number. Okay. All right, so let's do this. All right, we have, okay, 2 pointers. So what do we do? Well, first of all, what we want to do is band. Well, we have an int I equal to 0. This is the index for band, and we need sum, right? What else do we need? We need number. I'll call it j. J will start with a 1, and the rest will be 0. Okay, we say while, okay, I smaller than band dot length, ooh, size, and j smaller equal to n, okay. Actually, no. Let me think. Yeah, that's fine. It's fine. We can just say if let me think. What would be the best way to code this? And also, I'll say band length equal to band dot size. Okay. So we'll put it there. I'll put it there. This band length, right? And we'll say while I smaller than band length, and write band I is equal to band I minus 1. Then we say I plus plus. So I has to be larger than 0 as well. Right? So if these, so basically move I forward, right? Move I forward if we hit something that's we have duplicates. Oh, and also we need to sort. Damn it, I don't know how to sort. Okay, C++ sort vector. How do you sort a vector? Oh, just sort. V dot begin, V dot end. Do we have to say compare every single time? Stable sort. Wait, what's stable sort? Maintains the element order. I don't really care about that. Okay, now I look into this sort. Yeah, I think I just first and last. We can have a comparison, but it's not required. With respect to yeah, I think by default it should sort increasing. What's the default? Default is okay. Yeah, we can do this. Dot begin and dot end. So we say sort. There we go. Oh, we have to say include algorithm. I don't know that. Band dot begin, band dot end. Okay, we sorted it. So we do that, and we say if j is equal to band I, right? If they're equal, then j need to move forward. Oh, what the hell? J need to move forward, right? We say j need to move forward, and I need to move forward. Yeah. Else, if it's not equal to, then we say, ooh, wait, hold on, one more thing. And sum is smaller. Wait, the max sum does not exceed. Okay, smaller equal to max sum, right? So else we can say sum plus equal to holy crap. So if I add one, okay, that's fine. So we plus equal to j, right? Because j is not banned, so I add it, and I also do j plus plus. So regardless, j will be plus plus, right? In this case, j will be plus plus. And now we come out, right? After we come out, we need to check, right? We need to check. So either we go through all band. Ooh, hold a second. I shouldn't put it here, because if I go through the whole thing, that is okay. As long as j and sum is fine, we are fine, right? We just keep doing this, and I is smaller than band length, and right, if this is the case, then we keep going. If it's not, then there's no more band, and we just keep doing this, and eventually we'll get out either j equal to n. Oh, where's the res plus plus, right? So when you get out, either so sum plays equal to j. So we take j, right? We take j, and then sum get to a value, and then j we move on to the next one, and the rest we take the j, and then when it gets out, we need to check sum, right? We need to check sum. So we say return sum is smaller or equal to max sum. If that's the case, then we return res. Otherwise, res minus 1. Because I do sum plus equal to j, and then res plus we take j. But if we take j and it's bigger, then we need to remove it. Okay. So this is kind of what we're looking for. Let's give this a shot. And I want to also make some other changes. Let's make sure that this pass. Okay, this pass. Here's what I want. I know I can do. Actually, I'm not sure. Initialization, right? C++ initialize multiple variable in one line. How do I do that? Look at that. Look at that. So I can say, wait, is it a comma? Yes, it's a comma. So I can say sum equal to 0, j equal to 1, res equal to 0. Okay. And then band, this is a separate thing, so I want to do it here. And then we do this, And then you notice j++ happens at both, so I can take away j++, put it here. Okay. What's this? 2554. 2 pointers again. So it's gonna be OM plus N, right? Because you go N and this is M. Okay. I think I'm ready. Run it one more time. Make sure everything compiles, everything runs. You wanna try? Yeah, let's try it. Oh, maybe there's some edge case I didn't consider before. Oh, why does it take so long? 54 milliseconds. Yeah, I guess it's fine. It just take a long time. All right, we'll avoid the thing that caused us issue last time. What did I do last time? I do a set. I do this. I do this. Each one, if it's not in band, huh? That's actually a good idea, right? Why was it wrong? I even say I check this one first. Count plus equal to 1. Huh, interesting. I don't know. This looks good. This looks very good to me. If I not in band, yes, we'll plus this. And then we check it's smaller, then we take it. And then we check the next one. I actually don't know. Wait. That looks the same to me. Oh. Should be smaller equal to. Ah, that was an oversight. Did they increase the number of test cases? Too late. It's the same number of test cases. Binary search. Ah, yeah, you can do binary search. Sweep. What does sweep mean? Oh, shoot. It's not OM plus N. We have a sort. Yeah, M log N. Damn it. M log N. Is this what we do? I think this is what we do. Hash set. It's simple, but takes time. So C++ is unordered set. So unordered set, band set, you put begin and end. Now count, interesting. I wonder how much performance. You know what? Let's try this. I think it's interesting to do it again. Yeah, it can be like a solution 2 kind of thing. I've never written solution 2. This is actually. So we're gonna do this. This solution will uses a set. Uses a set. It's easier to write and technically faster, but I'm not sure whether the overhead of a hash of a set will neutralize the performance boost of not having to sort. Okay, so what they said is probably STD, right? Unordered sort, unordered set, int band set. We directly say band dot begin, band dot end. Interesting setup, right? And then for int I equal to 1, I small equal to, and I plus plus. We probably need a rest equal to I see. This is optimal. If band set dot, I have contains. It has contains. If it contains I, let's say if it's not contain I, right? If it doesn't contain I, then we say max sum minus equal to I. If max sum is larger or equal to 0, then rest plus plus, else break, and then we will return rest. Okay, let's take a look. It work? Oh, solution. If you take a look, the two are not exactly the same, but it's the same idea. No, it's much, it's much longer. So it's, yeah. Although it is, although time complexity is better, this solution is slower due to the overhead of set operations. Okay. Yeah, I would like to say that will be it. I kind of don't want to keep going today. All right, let's call it a day, and yeah, let's just call it a day. I don't have the Ghana, or okay, I have some Ghana to do a new one. I have no Ghana to do this one. Yeah, let's do a new one. Don't we have a new one that we just have around? Oh yeah, this one also I haven't even solved yet. I remember we have something. I think I did a previous contest. Yeah, let's just randomly pick some context. Let's just do this, just for fun. Identify the largest outlier in an array. An integer array nums contains n elements. Exactly n minus 2 are special numbers. Special numbers. What are special numbers? One of the remaining two elements in the sum of these special numbers, and the other is an outlier. Okay, n elements, n minus 2 are special numbers. One of the remaining two is the sum of these special numbers, and the other is an outlier. An outlier is defined as a number that is neither one of the original special numbers nor the element representing the sum of those numbers. Note that special numbers, the sum element, and the outlier must have distinct indices but may share the same value. Return the largest potential outlier in nums. 2 plus 3 equals 5. Largest potential outlier. Okay, so first thing we'll sort it, right? We'll sort it, and you start adding. The input generated that at least one potential outlier exists, but there could be multiple potential outliers, right? That's what it's trying to say. And this, you add these, will be this. So you add this, will be this. Okay, so if I sort the numbers, right, and I want the potential outliers to be big. So we have a potential outliers, and then we have the rest, and you say we add them together. So the smallest add together is equal to the biggest, then the potential outlier is going to be the second biggest, or add together is the second biggest, and then the potential outlier is the biggest, right? So that's kind of the two. But it may be the case where you have the sum, yeah, it's not necessarily getting big because you also have the negative values. But basically, what you're trying to say is we'll have one number that represent one number represent the sum of every other number, and how do I know that? Maybe we can do a prefix sum for this. We do a prefix sum, and we sort it first, then we do prefix sum. If I can find all instance of the sum, we can get a total sum, right? And just pick two values, right? We just pick two values. Basically, we pick one value. We remove one value, and the remaining need to be even. If it's even, we divide it by 2, right? And then we just need to see if one of the value exists. If it exists, then that will work. So we just need a set of nums. Okay, I think I have a solution for this. You want to practice now? No, I just do Python on this. All the additional will be in Python. 3371. 3371. We have more than enough chance to practice C++, so it's okay. And these regular problems, we just throw it to Python. Right, so basically what we're saying is we'll get a s equal to sum. We just sum the whole thing, and num set. Right, we get a set of nums. Right, and then we say largest sort nums dot sort. My God. And we say for n in nums, we'll go from right to left, right? If s minus n mod 2 equal to 0. Ooh, that's actually, I forgot. Hold on. Let's say minus 10 mod 2. Oh, okay, it's still 0. That's good. All right, so if it's equal to 0, right, and might as well we just say quotient and remainder div mod s minus n2. Okay, and then we say if r is equal to 0 and q in num set, now we return n. What do I return? It will always work, so I just return -1. I can say we shall never reach here. Okay. Let's go through this, make sure that it's working, and we will. Yeah, I think it shall work. Try each number in num from large to small and see if it can be the outlier. Right. For a number to be outlier, the condition is that the sum of the remaining numbers must be even, and half of it must exist in nums. Okay, so log n because we sorted it, and the rest should be fine. Okay, let's copy this, put it here, let's submit it. Oh my God. Oh my God. All right, I did not expect that. What? Output 13. I say 13. Expect -35. Oh, this is very wrong. Okay, that's fine. That's fine. You know, we simply just go down here and we do debugging. Always a pleasure to debug. Oopsie doozy. I did it wrong. It's okay. So basically, we're gonna say this. Didn't work. Command C. There we go. Negative 35. Okay, this is very weird. Alright, so we have nums, and this is get largest nums. Okay, let's do this. Save it. F5 1. Okay, so S is what? 39 is the total sum. Okay, we have a num set. Hold on, let me move this one bigger. All right, we have a num set. Okay, everything. And then a num is sorted. Good. So we from here, right? So we say 50. S minus 50. So S minus 50 is, but it cannot be, S is 39. 39 minus 50 is minus, is that 29? Yeah. And mod 2, it's not even, right? It's not even. So we don't consider. So next is 41. Minus 39 is negative 2. Right? It's negative 2. So quotient is negative 1. But the negative 1 is not in a set. So we say nope, no good. That's 37. 37 quotient is 1. Yes, and then say okay, it's not in. Next is 13. Now let's see what happens 13. So 39 minus 13 is 26. Oh, is itself. Oh, got it. So it cannot be itself. Actually, no. All right. In this case, I shouldn't even be in a set. I think I need a counter instead. I need a counter. Well, if it's really in the competition, that will be really sad. All right, nums. Actually, this should be counter. Okay, nums counter. But everything else will be similar. So it should be a nums counter q is larger than 1, right? Because actually no. What I need to see is, because I'm taking n out, right? I'm taking n out, and I need to know if there's another q. How do we do that? How do we do that? I know how to do that. So nums counter n minus equal 1. And we say if this is larger than 0, right? Otherwise, yeah, just kind of backtracking. Right? Nums counter n plus equal 1. Yep, just a little bit backtracking here. That shall work. Oof. I think I typed something wrong. Okay. I think I pressed the wrong button earlier. All right, put this in. Didn't think about it. Didn't think about this counter thing. Yeah, I should have realized when to use counter. Well, it's not a good performance, but we got it done. Yeah, this is not really hard. Oh, cannot see the solution. I need better solution. Hashtag. Wow, I haven't read his stuff for a while. Yeah, you have to use a counter. Okay, so yeah, that's good. Just for fun. That's completely just for fun. I didn't do it for any other reasons.